Yeah, hi. Hi everyone. Hi. Good evening everyone and welcome back to our YouTube channel. My name is Pooja Bhagat and I'm working as an associate data scientist in AiSPRY. So, welcome to today's live session in our Python series. So, we are going to explore a very interesting concept that iterators and generators in Python. The subtitle says that understanding lazy evaluation in Python, and that exactly what we will do today. So we will understand how Python handles data efficiently, especially when working with large data set or streams of information. So many times when we look through a list or use a compression, Python process all the elements at once. Okay, so but with the iterators and generator, we can make our code lazy, meaning like it only produces data when needed. This approach saves our memory and improve performance. Okay, so let's start with now begin with our basic things. Now begin with the basics, like what exactly are iterators and iterables in Python. So let's start with the term iterable. Iterable is it's a simple any Python object that we can loop over. For example, a list, tuple, string, or even a dictionary. All of these are iterables. What makes them iterables is that they can return something called an iterator. Like when we pass them to the built-in iterator function. Okay, so you can think of iterable as a container that holds multiple items and it allows us to access those items one by one. Okay, now what about an iterator? Okay, an iterator is an actual object that does the iteration. It's the one that remembers where it is a while looping and give us the next element each time we ask for it. So in a Python, we can get the next item from an iterator using built-in function. Let's look at the short example here, like list 1, 2, 3. So here is a nums is a list which is an iterable. When we call iterator function, that nums, we get an iterator object that allows us to fetch one element at a time. So when we write next, when we write a next it, so Python returns the first element, which is 1. If we call next again, then we will get the next element and so on like that. Okay. Then and like once all the elements are exhausted, Python will raise a stop iteration error to signal that there are no more items left. So in the next slide, we will see how we create our own customer iterator class and control the iteration process ourselves. Okay, so we are creating a custom iterator. Now that we understood what iterators are, so let's take it one step further and create our own customer iterator in Python. The best way to understand iterator deeply is actually build one yourself. Okay, here I have created a class called a counter. Let's go through its line by line, like class counter. So this is our initialization method. As you can see, define init, init, that initialization, that whenever we create an object of this class, it takes two numbers, start and end. This value tells the iterator where to begin and where to stop counting. Okay, so we also store the so the current value like in a self dot current. Okay, which will keep track of where we are in a iterator process. Then next we define that iterator method. Okay, like here as you can see here, define iter self, return self, that this method simply returns the iterator object itself. In other words, this tells Python, yes, I'm iterator and you can use me in a loop like that. Okay. So now the most important part, the next method. Okay, the next. As you can see here, we define the next. Okay. So this is where the actual iteration logic lies. Every time Python calls next, okay, every time Python calls next on this object, this method runs, then first it checks if the current value is greater than the end value. That means we have reached the end of the sequence. In that case, it drives a stop iteration exceptions to like signal that there are no more values left. Okay. Or otherwise, it increases the current value by one and returns the previous value, which give us the next number in the sequence. Okay. So let's say we create, for example, let's say we create an object like numbers is equals to counter 1 5. Okay. So when we use a loop, okay, when we use a loop like for a number in a numbers, print a number, okay, it will print 1, 2, 3, 4, 5. Okay, one number at a time. Behind the scenes, Python is repeatedly calling next for until stop iteration is right. So with this example, you can see that an iterator is not just built-in concept. You can create your own logic for iteration. Decide decide how values are generated and when they stop. In the then in the next slide, we will simplify this concept using generator, which lets us do same thing like but with much less code. Okay, generator and their yield keyword. Okay, now that we have seen how iterator work and how we can create our own using classes. Okay, so let's move on to something much simpler, generators. Generators in the Python are a shortcut for creating iterators, but with a much less code. So instead of writing a whole class with iterator and next that methods, we can create a generator using just a simple function and a yield keyword. Okay, let's look at the code example on this slide. So we are here defining a define squares and for I in a range 1 n plus 1. This function looks very similar to a normal function, but there is a one important difference. Instead of using return, we are using here yield. So what does yield actually do? So whenever Python encounters a yield statement, it pauses the function's execution. Okay, it saves its current state and return the value to the caller. The next time we call next on this generator, Python resumes execution from where it left off. Okay, now from the beginning of the function, this means the function does not lose its local variable or progress. It continues exactly from the previous state. And that what makes it so powerful and memory efficient. So let's try to understand with an example like for example generator is equals to squares like a 3. It will print first next generator. It will first show 1, then print next generator, then it will show 4. Like each time we call a next, then next function, it resumes from the next value of I. Like calculate I, multiply I, and it is that the result. Okay. So the output will be the 1, then 4, then 9. And once there are no more value left, Python automatically rises the stop iteration, just like with the iterators. Okay. So in the next slide, we will see an even shorter version of a generator called generator expressions, which look just like a list compression, but work in a much more efficient way. Okay, so generator expression. So, like so far, we have learned how to create a generator using the yield keyword inside a function. Okay. So, but Python makes our life even easier. It's gave us something called generator expressions. Generator expressions are just a compact and a clear syntax to create a generators. We can think of them as a generator version of a list compression. Okay, so you might remember the list compression like this for example here x star x multiply x for x in a range 5. This create a complete list of a square from 0 to 4 all stored in the memory. Now if we simply replace the square bracket with a parenthesis, we get a generator expression. Let's see the example from this slide. So here you can see like generator equals to x multiply x for x in a range 5, and we just printing like print next gen using our parenthesis. Okay, so here generator that gen it becomes a generator object, not a list. Okay, so that means it does not store all the values in memory at once. Instead, it generates each value on the fly, like one at a time when we export it. Okay. So when we call a next, it gives us a first square which is 0. Then if you call a next, then again, then we will get the next value which is 1. And it will continue until all values are exhausted. Then the biggest adventure here is a memory efficiency. Like with the list compression, if we had something like a million number, Python would create and store all 1 million results in a memory at once. But with the generator expression, Python generate each value only when needed. Okay, so making it perfect for a large data set or data streams. So okay, so in the next slide, we will compare iterators and generators side. Okay, side by side. Okay, so you can clearly see when to use which one. Okay, so now that we have learned about the iterators and generator, it's time to clearly understand the difference between them. So both the iterators and generator help us to iterate through the data one item at a time. Okay, so but the way they are created, the way they work, it's a quite different. Let's go through each point one by one. The first point says iterator, then uses iter function, then next method. Okay. So this means when we create an iterator manually, we have to define these two special method inside a class. The iteration method with it returns the iterator object itself. Then and the next it defines how to get the next value. So iterator give us a full control. But the downside in that they require more code to write and maintain the next like okay. So the next point says generator uses the if statement in the functions only. Okay, so this is the simpler way. Instead of writing the entire class, we just define a normal function with the yield keyword. The function like automatically become a generator, and Python take care of creating that iterator and next methods for us like behind the scenes. Okay, so generators are like automatic iterators. Okay, so we get the same functionality but with much less effort. So now the next comparison, memory uses. So, generator are a more memory efficient because they don't store the entire sequence in memory. They generate each value only when needed. Okay. So, iterator, depending on how they are written, like might hold our more data or state in the memory, especially if they are based on large lists or structures. Okay. Then finally, code length. Okay, generator are simpler and shorter to write. Okay, so while iterator require defining a class and writing the multiple methods. Like now that we know how they are different in the final slide, we like okay, so they are bit different only. Okay, so in the final slide, we will talk about the real world use cases of the iterators and generators and how they are used in every day in the Python project. Okay, so all right. So we have now reached our final slide. And let's take a quick moment to summarize everything like we have learned about iterators and generators. Throughout this session, we saw that both of these concepts are built around the idea of the lazy evaluation, which means instead of generating or storing all data at once, Python produces value only when they are needed. Okay, so this lazy approach helps our program run faster and use less memory and handle very large data set efficiently. Okay, so now let's look at a few real world use cases where these are very useful. First one is reading large files line by line. It means like instead of loading entire file into a memory, we can use a generator to read one line at a time. This is a perfect for working with a huge log files or a CSV file. Then next one is a infinite sequence. It means generator can create an infinite series, generating numbers one after another without stopping. Since values are produced only when needed, then the program never runs out of memory. Okay. The next one is data pipelines in a machine learning. Then uh, when we work with massive data sets, generator allow us to fit data to the model in a batches. So instead of loading the full data set into the memory, this makes our ML workflow much efficient. Okay, like much more efficient. So the take whenever you are working with a large or a continuous data, try to think that can this be done with the generator instead of a full list like that. So most of the time, the answer is yes, and that small change can make your code both cleaner and a faster. So that's all for today's session on iterators and generator. I hope this session helped you understand how Python handles that data lazily and how you can use this technique in your own projects. If you found this helpful, make sure the like video and subscribe to our channel. Thank you so much for joining this live session. Keep learning, keep coding, and I will see you in the next one. Okay, thank you everyone.